Good morning. Hello, my name is Amanda Chavez.
And my name is Brianna Suera, and we are fifth graders, and we are from Cesar Chavez Elementary in Pharr, Texas.
We are both happy to represent our school in all of South Texas, and our science question is,
How does microgravity affect the mold growth on food? But first, we need to define what mold is. Mold is a furry growth on minute fungal that typically grows on moist conditions and environments. It is part of the fungi family kingdom.
the conditions for mold to grow are mold spores, mold food, appropriate temperatures, and considerable moisture. These are some pictures that show the growth of mold. Mold comes in many sizes and colors.
The materials needed to conduct our experiment are Gerber graduates for toddlers, little biscuits, 2 grams, Aquafina distilled water, 2 milliliters, Nanorack test tube, clamp, triple beam balance, and a dropper. Our first earthbound experiment was tested with different amounts of water. We needed to see how much water was needed for the ideal mold growth, not too fast nor too slow. Since we have limited amount of time, it could change our experiment due to time frame of return. The one that grew the best amount of mold at a good time was the one with equal amounts of water and biscuits. The variable for our project was the amount of water. 2 grams plus 2 milliliters of water equals optimum mold growth. The procedures for conducting our experiment are first put the Gerber graduates for toddlers, little biscuits, 2 grams inside the Nanorack test tube.
Then pour the 1, 2, and 3 milliliters of Aquafina distilled water into the 3 separate test tubes.
Finally, we will slowly open the clamp, letting the distilled water drop, giving the Gerber graduates for toddlers, little biscuits to start growing mold.
To find out the mold growth rate difference between the one in microgravity and Earth, we will do an exact replica of the experiment on Earth at the same time as the experiment conducted in microgravity. Our conclusion is that the ideal mold growth happens when there is an equal amount of biscuit and water.
Our next slide has to do with mold in microgravity. Microgravity, also known as zero gravity. The condition of microgravity comes about whenever an object is in free fall. When an object is in microgravity, it appears to float. Astronauts on the stations experience weightlessness due to microgravity.
Our hypothesis is that mold will grow faster in microgravity than here on Earth because the mold spores are adapted to gravity. In microgravity, there will be no pressure to contain the growth of mold. We expect the mold to grow 2 times faster in microgravity than here on Earth due to our following reasons. Once the water is released by the clamp in microgravity, the water will be floating around until the little biscuit absorbs the water in different areas. Then mold will start growing in different areas due to the parts where the water landed on. Finally, the mold will release mold spores onto the air, and thanks to microgravity, these mold spores will spread all around the biscuit, creating multiple numbers of colonies. These multiple numbers of colonies will help the biscuit grow faster in microgravity than here on Earth.
The materials needed to conduct our experiment in microgravity are the same as in Earth, as you could see in the screen.
The procedures to conduct our experiment in microgravity are first put the Gerber graduates for toddlers, little biscuits, 2 grams inside the Nanorack test tube, volume 2, which will be separated by a clamp.
Then pour the 2 milliliters of Aquafina distilled water into volume 1.
Finally, on A+2, 2 days after the arrival, the astronauts will slowly open the clamp, letting the distilled water drop, giving the Gerber graduates for toddlers, little biscuits moisture to start growing mold.
As for our conclusion, we are still pending the return of the experiment. We expect to find the mold will grow faster in microgravity than on Earth because the mold spores are adapted to gravity. This concludes our presentations. Everything was possible thanks to our supporters.
Does anybody have any questions for the Pharr Texas team? And while you may be coming up here, let me just say, what a superb job, future doctors Azwara and Chavez.
Hi, Joanne Olawale from East Lyme, Connecticut. Ladies, you did a wonderful job. My question is, how does your findings benefit the astronauts?
It doesn't really help the astronauts. Is to stop, grow, or even control mold differently here on Earth.
I'm Noah Barnhart from East Lyme, Connecticut, and my question was similar to hers, and it was, why are you trying to find the ideal condition for mold to grow? Wouldn't it be the opposite?
Can you repeat your question?
I said, why are you trying to find the ideal conditions for mold to grow? Wouldn't it be the opposite?
I think he's asking, why would you like to find the ideal conditions for mold to grow? If you don't want mold to grow, is it better to find the conditions that are good for mold not to grow?
By studying mold and microgravity, we will be able to learn how to stop, grow, or even control mold differently than here on Earth. And these conclusions will later help us understand and see mold in a different perspective. And maybe one day this will be able to be used on Earth.
Very nice, Team Pharr.